Hi everyone. Today we're going to be looking at equations of lines and just reviewing what is a slope, what is slope-intercept form of a linear equation, and point-slope form of a linear equation. So you can watch this video and follow along with the guided notes. So first thing we're going to look at is slope, and that is the rate of change between 2 points on a coordinate grid. The slope m, we use this letter m to represent the slope in our equation, is the ratio of the vertical change, or the rise, to the horizontal change, or the run, between any 2 points. We use this term rise over 1 to help remember that it is the vertical change over the horizontal change as a ratio. I sometimes tell my students that you must raise your foot before walking on the stairwell. Otherwise, you're just going to slide your foot into the stairwell and fall. So just to help you remember, it is raising your foot up first and then moving it as you're climbing the stairs. So rise over run. We use this formula y2 minus y1 over x2 minus x1. This second y value, subtract the first. Second x value, subtract the first. 4 examples of slope. Here's our positive slope. It's going up to the right. Negative slope means it's going down to the right. Zero slope, it's not changing, right? It's not going up or down. And undefined means it is vertical, right? This one is the only one that is in the form x is equal to for our equation. The rest are all y is equal to, because in this one, the x value never changes, right? There's an infinite number of y values or solutions, but the x value will never change. A little side note there. All right, let's take a look at the first ones. How do we write equations of lines in slope-intercept form and point-slope form? So the first one, slope-intercept form, is in the form y equals mx plus b. Why do they call it slope-intercept form? Because you're given the slope, and b represents the y-intercept. Hence, slope-intercept form. So if we're given a problem that says we know the slope is 3 and the y-intercept is -5, we can substitute those into our form, our equation, and have a nice slope-intercept form of an equation. Slope of 3, y-intercept of -5. Point-slope form, we need a point and a slope. So it looks like this: y minus y1 equals m, x minus x1. So there's a couple things I want to point out here. So the first one is slope, we know is m. A common error that I will see with my students is that we will put, when you're given 2 points, you put a value for x in both of these or in y for both these. But please be very careful. The point that we know is only going to be the x value of that point and the y value of that point in these 2 spaces. So our point is x1 and y1. We are going to leave this x as x and this y as y, because that's our input with that output. Let's take a look at an example. What is the equation of the line through -1, 5? I'm just going to label this x1 and y1 from the start with slope of 2. So you can see here the slope of 2 goes in for m. x1 is -1. y1 is 5. I want to point out that when we substitute that into our equation, that y minus y1, or y minus 5, slope of 2, x minus a -1. One of the biggest errors I will see with this problem is that students will write x minus 1 because they immediately see this is supposed to be negative, so they leave it as -1. But it is not true. It's subtracting a negative, which changes it to a positive value. Here's our point slope form through that point with that slope. Let's try a few examples. What is an equation of a line with slope 8 and y-intercept 10? We're going to write this in slope-intercept form, which is y equals mx plus b. We know our slope is 8. We know our y-intercept is 10. This is actually a pretty quick one. Y equals mx plus b. So y must equal 8x plus 10. and you're done. The second one says, what is an equation of a line passing through 3, 3 and 4, 7? Let's write it in point slope form and then convert it to slope intercept form. So we're going to first write it in y minus y1 equals m x minus x1 and convert it to slope intercept form. Now you notice here we don't know the slope, m. That is something that we will have to find to solve and write this problem. So just a reminder, our slope formula is y2 minus y1 over x2 minus x1. I'm going to label this x1, y1, x2, y2. So I can find our slope as 7 minus 3 over 4 minus 3, which means that we will get 4 over 1, which equals 4. Now we have enough information to write this equation. So again, we're going to write this equation as y minus y1 equals m x minus x1. I'm going to choose one of those previous 2 points. I'm going to choose 4, 7 for this problem. You can choose 3, 3. That's okay. I'm just going to choose 4, 7 for now. I could write this as, I'm just going to write this here, 4, 7, and we know our slope is 4. So I can write this as y minus 7 equals 4 x minus 4. Now, if you had written that with the other point, do you remember the other point was 3, 3? This formula could be written as y minus 3 equals 4 x minus 3. Okay. These are both correct. These both represent the same linear equation, but we're going to now convert one of these into slope-intercept form. I'm going to choose this one. You could have chosen the purple one, but I'm going to use the green one for now. So what you can do to convert this, again, we want to convert this to slope-intercept form, is we can actually distribute that 4 into the parentheses to get y minus 7 equals 4x minus 16. And then we can add 7 to both sides to get y equals 4x minus 9. If you did this same process with the purple equation here, it would come out to the same slope-intercept form of the linear equation. Let's take a look at some graphs. What is the graph of y equals 2/3 x plus 1? Well, as I look at this graph, I can say that it is in slope-intercept form, which means I know the slope and I know the y-intercept. So when graphing, this actually makes life a lot easier because I know the y-intercept is 1, which is going to be here on my graph. And I know the slope is going up 2 over 3. So from this point, I can go up 2 over 3, up 2 over 3. You can even go in the reverse order, down 2 to the left 3 to draw that line. That was a good line. What is the graph of y minus 3 equals negative 2 x plus 3 times x plus 3? So this is a little different. This is in point slope form. I still know the slope is negative 2, but this is where you have to be very careful. The point that is given in this problem, remember it's y minus y1 and x minus x1. That means my x value, notice how this is supposed to be subtraction, and it's addition here, so this actually changed. It changed because our value was negative. Our y value, it's supposed to be y subtracting y1. It is subtracting y1, so our y1 is just 3. The nice thing about point slope form is I can now graph this point, which is at negative 3, 3, and then use this slope of negative 2 to go down 2 over 1, down 2 over 1, down 2 over 1, and continue that process. All right. Let's look at a few more examples. Graph y equals 3x minus 4. The slope is 3. The y-intercept is negative 4. So I'm going to start at a y-intercept of negative 4, go up 3 over 1. That's a good line. Let's look at this one. Now, a very common thing I see students do is they want to convert this to slope-intercept form. They're just comfortable with slope-intercept form. I don't suggest that. If something is given in point-slope form, use point-slope form. The point you are given here is that the x value is going to be 4. The y value will be 2. Just want to show you real quick, and I'm going to do this in red, so it's just a helpful way of saying don't do this. Or you can, but it's just harder to graph. So I would have to distribute this negative 1/3 to each of those terms to become y minus 2 equals negative 1/3 x plus 4 over 3. And then if I were to add 2 to both sides, my y-intercept is not going to be a whole number. Because I would have to take this 2, make it so it has the common denominator with that fraction, and then add it. So 10 over 3 is not really a nice number to graph, right? That would be 3 and 1/3. Not very nice to graph. So I'm just going to use this point for 2. 1, 2, 3, 4. 1, 2. My slope is negative 1 over 3, so I'm going to go down 1 over 3. Uh-oh, that's going to be off the graph. So let's go the opposite way. Up 1 to the left 3. Up 1 to the left 3. Up 1 to the left 3. Remember how I said the y-intercept was 3 and 1/3? This is going through 3 and 1/3. Not perfect, right? Let's see. 3 is here. Oh no, it's not too bad. 3 and 1/3. But we would not have been able to start with that. So my suggestion is always going to be graph starting the point and use that slope negative 1/3. I hope this video helps.